Sup, it's Mr. Wicklehouse, and today we're solving quadratic word problems. Okay, so let's just get right into it. We know how to solve quadratics for the most part already. So this is just reading the word problem and interpreting it. So Oliver hits a baseball 3 feet above the ground with an initial velocity of 80 feet per second towards the outfield fence. A quadratic equation models the flight path of the ball with respect to time. Okay. So here we've got our function h of t, and h of t equals negative 16t squared plus v naught, which is the initial velocity, times the time, plus h naught, which is the initial height. So we can see the variables are defined by each one: time, the height at the time t, the initial velocity, and the initial height. And they want to know how high is the ball after 0.5 seconds, what is the maximum height of the ball, and how long does it take to reach its maximum height, and then they also want to know when will the ball hit the ground. Okay, so here's what we do. So they gave us the equation already, and they want to know, for part A, how high the ball is after 0.5 seconds. Well, that 0.5, that's just t, so I'm going to plug it in for t. Okay. You may be asking, where did this 80 and where did this 3 come from? Well, looking back at our problem, we can see that we've got 80 feet per second, and that's the velocity, the initial velocity, and we've got 3 feet above the ground, and that's the initial height. So all I'm doing is I'm taking 80 and putting it in here for v naught, and I'm taking 3 and putting it in here for h naught, and that's how I got negative 16t squared plus 80t plus 3. Okay, so now that I've done that, I'm going to plug t in. So h of 0.5, so everywhere where I've got a t, I'm just plugging 0.5 in, put all that stuff into my handy dandy calculator, and I get that the height of the ball after 0.5 seconds is 39 feet. Okay, pretty easy, not too bad. That one was easy. The rest of them aren't that bad either. Okay. Part B asks, what is the maximum height of the ball, and how long does it take to reach its maximum height? Well, remember from one of our previous videos, we talked about the maximum and minimum of a quadratic function. And where does that happen at? Do you remember? That's right, it's the vertex. Okay, so what we're doing here is we're looking for the vertex. So what we're going to do is I'm going to go into my calculator, and I am going to graph it. Clear this out. And we're going to put negative 16x squared plus 80x plus 3. The variables don't matter so much. And I'm going to graph it. Here we go. What's going to happen here? Waiting for my graph. Oh my goodness. Is that it? That doesn't look like a quadratic, does it? Well, let's zoom out a bit. Okay. So, let's see. X minimum, let's change that to, let's go to 25. I don't know how this is going to work out. 25, we'll go in increments of 5. Change the Y minimum, that'll be fine. Change the maximum, let's change it to, I don't know, let's do 125, it will go in increments of 5 again. Let's try graphing it again. See what happens this time. There we go. There's our full picture here. So where's our vertex at? And I hope you're thinking that the vertex is right here at the top, because that's where it is. That's the vertex. And we can see, because it's upside down, that that's going to be a maximum value because it's at the top of the hill, right? Alright, so let's find where the vertex is. So what we want to do is hit second button, then come over here and hit trace. And we're looking for the maximum, so this couldn't be much easier, so we're looking for the maximum, so right there, that's what we're going to pick. Okay, now it's, as usual, it says left bound, so we want to be to the left hand side of our vertex, and we'll hit enter. Now it wants to be on the right hand side of that, and we'll hit enter. Now it's going to say guess. Yes, I want you to guess to tell me where it is. There we go. We get 2.5 and 103. You guys might be wondering, what do those numbers mean? Well, x is the time that it takes to reach that maximum height. So it took 2.5 seconds to reach the maximum height. And the maximum height that it reached was 103 feet. Okay, so there's that part. One more part, part C. So they want to know when the ball hits the ground. Well, we know that the ball hits the ground when height is 0. So h of t equals 0, so that because that represents the height. So I'm going to plug 0 in for that. Now we can see we've got 0 equals this quadratic. So remember, we've been talking about when we solve quadratics, they have to be equal to 0. So this is one of those situations where we're going to solve the quadratic. So we'll solve the quadratic using the quadratic formula or by graphing it. If you want to use the quadratic formula, that's fine. But I'm not going to. I'm going to use my calculator. Okay. And I can see here, here's my picture. So again, I'm going to go in to second, calculate. And remember that when we were solving using graphing before, that I go in here to the zeros. Again, it's going to pick the left bound. So I've got one down here. And I've got one over here, but I'm going to do this one first. So there's my binding. Wants to guess. And that value is negative 0.037. Okay. Going to do it again for the other one. So there we are there. That's to the left. And now I'm going to go to the right and hit enter again. And I can see that this one is 5.037. Okay, so there's my two values that I got. You get something similar to this when you use the quadratic formula. So we've got negative 0.04 and 5.04. Well, I can't have a negative time because that doesn't make sense. So my answer is just 5.04. Okay? 5.04 seconds, and that's how you would do that. Let's look at another type of problem. So here we've got this problem. It says a designer plans a walkway around a garden, and the garden is rectangular with its length being 3 meters longer than its width. The area of the garden is 93 square meters. What are the dimensions of the garden? Round to the nearest tenth. Okay. So, I know that the length is 3 meters longer than the width. So I need to assign a variable. And I'm going to say that my width is equal to x. Okay. And then I know that my length is 3 meters longer than that. So I know that that's x plus 3. It might help you to draw a picture so that we can lay out our variables on there and help us think about it. They give me the area. So when they give me the area, I know that the area of a rectangle is equal to length times width, which means that the length, x plus 3, times x is going to be 93 square meters. So I can write that out. Okay. Now then, to simplify this sum, I'm going to distribute the x and get x squared plus 3x equals 93. And then I subtract the 93 to the other side, and I get x squared plus 3x minus 93 equals 0. Okay. This one will use the quadratic formula instead of graphing, and you don't have to. You can use the graph if you want. But just for fun, say a equals 1, b equals 3, c equals negative 93. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which means that negative b is negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 93 all over 2 times 1. And that is what I'm going to put in my calculator. Okay. So I'm going to do negative 3 plus, because I got to do this twice, second square root of 3 squared minus 4 times 1 times negative 93. I'm going to do that, and then I'm going to divide that by 2, and I get 8.259. Now let's do negative 3 minus the square root of 3 squared minus 4 times 1 times negative 93, and divide that by 2, and I get negative 11.259 again. Well, this is, if I round it to the 10th, is 8.3. This one is negative 11.3. Negative doesn't make sense for area or for length and width. I can't have a negative length. So there's my answer, 8.3 meters. So my width is 8.3. That's this way. The length is 3 more than that, so I add 3 to that and get 11.3. That's kind of the idea. You got to read these problems, decipher them, get them set up so that they're some kind of quadratic, and then solve. That's it for today. I'll talk to you later.